Before I start this video, I just wanted to say, if at any point this video doesn't make sense, you can go to Khan Academy or refer to your school notes, because both, I'm sure, are good things to refer to for learning this. This video is just one way to look at this subject. Alright guys, so in this video I wanted to talk about combination problems that include at least or at most. And what I mean by that, well, you'll see what I mean by that after I show you an example clarifying what I mean. Okay, so let's say we have the numbers 1 to 9. Okay, and we are taking 4 numbers out of that, and you want to see how many different combinations there are when we're taking 4 numbers out of this 9 element group. So without any restrictions, there are going to be restrictions in this video, but we've seen before that without any restrictions, this group and the combinations that we would get from taking 4 of these elements out would be 9 factorial, which is basically just the number of elements in our initial group factorial, divided by 4 factorial, how many numbers we're taking out, times 9 minus 4 factorial. Okay, and basically what we just did there, this is the same thing as permutations divided by 4 factorial. Okay, I think that's how we left it in the other video, but this calculates to 9 factorial divided by 4 factorial times 9 minus 4 factorial. Okay. In this case, right? With this situation's particular numbers, so it wouldn't always be 9 and 4. But anyways, that's how you would do it without any restrictions. So I'll draw these 4 positions out right now. Okay, that's without any restrictions. But in this video, I wanted to talk about it with restrictions. So with restrictions, this would look a little bit different. How we would do this is we would actually, let me tell you what the restriction is first. The restriction is, in this case, in this video, we're talking about at least and at most. So let's make this certain example an at least problem. So this at least problem will state that you need at least 2 even numbers. So that's what I mean when I say at least or at most. It requires you to take a certain number of elements that have some sort of characteristic. So in this case, at least 2 even numbers is requiring you to take 2 even numbers when you are taking out your 4 numbers. So how would we solve a problem like this? Well, we could actually split this situation into different scenarios. So I'll show you what I mean. The first scenario would be where you have 2 even numbers and then 2 odd numbers, right? Because we have 4 positions in total. And yeah. The other situation, right, would be if we had 3 even numbers. So we can't have any less than 2 even numbers, right? So the next scenario would be if we had 3 even numbers and 1 odd number. And then the last scenario that we could have in terms of even and odd numbers is just 4 even numbers. whoa, even numbers, and then 0 odd numbers, right? Okay. So these are all of our different scenarios for taking out 4 different numbers, and where we have to take out at least 2 even numbers, right? Now, if we calculated out the combinations for all of these, so the combinations we would have if we were to force ourselves to take 2 even numbers and then 2 odd numbers, the combinations that we were to have if we were to take 3 even numbers and then 1 odd number, and then the combinations that we would have if we were forced to take 4 even numbers, right? So if we calculated all of these and then added them together, so this plus this would equal the number of combinations where we actually have at least 2 even numbers, because we took into account all of the different scenarios, right? And then we calculated the number of combinations for each of those scenarios, and then we added them together. We would get the total number of combinations for at least 2 even numbers. Okay. So let's actually calculate this. So the first thing that we would do is we'd have to calculate the different combinations for taking 2 even numbers and then 2 odd numbers. Okay, so how would we do that? Well, let's start by breaking it up. So let's say we want to find out how many different ways we can just take 2 even numbers out of this group, okay? Well, there are 4 even numbers in this group, right? So if there are 4 even numbers, and we only have 2 positions, right, because we are taking 2 even numbers out, what this first position could hold 4 different numbers, right? Assuming they all have to be even. And then the second position could have 3 different numbers. Okay? Now, that multiplying these together, 4 times 3, would get out the number of permutations that we have, right? But if we wanted to get our combinations, we know that we just have to divide permutations by the number of positions factorial, so 2 factorial, right? And that will equal 6, right? So there are going to be 6 different ways we can take out 2 even numbers from this group of 9 numbers, okay? All right. So we have solved the number of combinations for taking 2 even numbers out. Now let's take out, let's find out how many combinations there are for taking 2 odd numbers out, and see how using both of these combinations will end up getting us the total number of combinations for this part. Okay, so 2 odd numbers. Well, there are going to be 5 odd numbers, 1, 2, 3, 4, and 5. So there are going to be 5 different odd numbers that we can choose from to fill positions. And we are only going to have 2 positions because there are 2 odd numbers. If any of this is confusing, I suggest you go back to the combination videos. Because I won't be giving an explanation for why I'm doing what I'm doing. I'm just assuming that you know how to take combinations and permutations. Okay, moving on. So this first position could hold. So first we're going to calculate permutations, then we'll calculate combinations, just like we did over here. But for this first position, we can have 5 different numbers, right? Because there are actually 5 odd numbers. Now for the second position, we can have 4 different numbers, because it can have any number excluding the number that is in the first position. Okay, so the number of permutations we have is 20. But we know we just have to divide 20 by, like 5 times 4 is 20. We just have to divide the number of permutations by the number of positions factorial, so in this case 2 factorial, to get us how many combinations there are. So there are going to be 10 combinations. Okay, so now we have 10 combinations for the odd numbers, and we have 6 combinations for even numbers. Now, something that we can do is we can actually multiply these together to equal the total number of combinations for taking out 2 even numbers and 2 odd numbers. Now, why does this make sense? Well, we can go back to our way of thinking with the tree, or that diagram that I had before. I'll draw it out. You start and you're going down a path, and at first you can go down a certain number of paths, right? And in this case, it would be 6 paths, right? So I'll draw 6 paths, 1, 2, 3, 4, 5, 6. 6 paths representing which combination you're sort of choosing for picking out 2 even numbers, okay? So to get the total number of combinations for picking out 2 even numbers and 2 odd numbers, first we're going to find out, first we're saying that because we have 6 possibilities for even numbers, for picking out even numbers, at the end of every single one of those positions, at the end of every single one of those sort of paths, after that, we can take 10 different paths after that, because there are 10 different options for picking odd numbers, a set of odd numbers, right? That's 5, 6, 7, 8, 9, 10. Okay, so it's a bit messy, but just pretend that those are 10 arrows. Okay. So at the end of each of these paths, at the first paths, right? So at the end of each of these paths that I'm pointing at with my mouse, that is going to be a different combination for picking out even numbers, okay? So maybe this is combination A for picking out even numbers, this is combination B, this is combination C, D, E, and F. So each of these combinations is a different combination for picking out 2 even numbers from this group. And then after that, we're going to pick one of the 10 combinations of 2 odd numbers from this group. And at the end of each of those is going to be a combination of both even and odd numbers. So there would be more arrows from each of these sprouting as well, but I'm not going to draw all of them. If the tree diagram doesn't make sense, I suggest you go back to the previous videos on permutations and combinations, because it explains what the it explains more about the tree diagram, sort of, or that path diagram. But just to recap, we're basically seeing for each combination of even numbers, we're going to see, so for each combination of even numbers, at the end of those even numbers, we get, for each of those combinations of even numbers, there's going to be a certain number of odd numbers as well, of combinations of odd numbers as well. Okay, so now that we know that there are going to be 60 different ways we can pick 2 even numbers and 2 odd numbers from this group of 9 numbers, now let's solve for this over here. Okay, so let's just erase this so that I have more space. We're just going to follow the exact same process with the even numbers and then the odd numbers. Okay, so to calculate the number of different ways we can take out 3 even numbers from this group, we know that there are 4 even numbers, right? So we're taking a certain number of even numbers out of a group of 4, and then we're putting them into 2 positions, okay? Right, because, oh sorry, 3 positions, because there are 3 even numbers here. Okay, so this first position here could have 4 different even numbers, right? Second position could have 3 different even numbers, and the third last position could have 2 different even numbers. Okay, so 4 times 3 times 2. That is our number of permutations, right? Which is equal to 24. Now, if that's our number of permutations, what is our combinations? Well, we just have to divide it by 3 factorial, right? Because there are 3 positions. What is that going to equal? 24 divided by 3 factorial is the same thing as 24 divided by 6. 24 divided by 6 equals 4. Okay, so there are going to be 4 different ways we can take 3 even numbers out of this group. Alright, now how many different ways can we take out an odd number? One odd number from this group. Well, we're only going to have one position, and we're taking it out of a group of 5 numbers because there are only 5 odd numbers, right? We don't include the even numbers because it's just an odd number. It has to be an odd number, so we don't even include the even numbers. So this one slot can have 5 different numbers. So we have 5, that is our number of permutations, and it's actually also our number of combinations because dividing by 1 factorial is just equal to 5. So the number of combinations for this is going to equal 5 times 4, right? The number of combinations here and the number of combinations here multiplied, and it will equal 20. So there are going to be 20 different ways to take out 3 even numbers and 1 odd number. Okay, how many different ways can we take out 4 even numbers? Well, let me make some space. Okay. We can take out 4 even numbers, so I'll draw out 4 positions. And we know that there are going to be 4 numbers that we're choosing from. So this first position can have 4, second position can have 3, next 2, next 1. Okay, so we get 4 times 3 times 2 times 1. And we would divide that by 4 factorial, right? Because there are 4 positions to get our number of combinations. And these will actually just cancel out, and it will equal 1. Because 4 factorial equals 4 times 3 times 2 times 1, right? So there is going to be one way to take out 4 even numbers from this group. What about 0 odd numbers? Well, there is also just going to be one way to take out 0 odd numbers from this group, right? If we're taking out 4 even numbers, that fills all of our positions, so we don't even include the odds because we're not even taking out any odds. So we don't even include it. So there's going to be one way we can take out 4 even numbers from this group. Again, we don't include the odds because we're not even taking out any odd numbers from this group, so we have no reason to include it in our calculation. Okay, so adding these together, we get the combinations for at least 2 even numbers is equal to 81. 81. So there are going to be 81 combinations to take 4 numbers out, assuming that there are going to be at least 2 even numbers. Okay, let's do another example. Except let's base it around most instead of at least. So let's do the same example as before. Oh, just with a different type of restraint. Okay. And let's say we have to have at most 3 odd numbers. Okay. So let's think about the different scenarios that we can have if we were taking out 4 numbers from this group. Those are 4 positions. Okay, so at most we could have 3 odds, right? And then that would mean that we have 1 even. We could have 2 odds, 2 evens, 1 odd, 3 evens, or 0 odd, and 4 even. Okay, so we have our scenarios, and we would just calculate it the same way that we calculated before. So that pretty much concludes the at most and at least, because you know how to solve them. It's just a bit different between the two when you're thinking about scenarios, because it's different when you're saying at most and at least. Now, something to take note is that if I were to say we need to take at most 2 odds, let's see which scenarios pop up then. Well, we can have 2 odds, 2 evens, right? 1 odd, 3 evens, or 0 odds, and 4 evens. Now, these are the exact same scenarios that we had from our last problem, with the at least a certain number of evens. And that's because saying at most 2 odd numbers is the same thing, or it results in the same restriction as saying at least two evens. Okay? All right. So, yeah. So that can happen sometimes, not all the time, but it can happen. Where two of like at most and at least will result in the same restriction. Okay. Now let's move on and talk about the last thing that I want to talk about is saying that you need an exact number of something. Okay. Let's say we're taking out 4 numbers once again, and you need exactly 1 even number. Okay. Well, it's actually going to be a lot easier than our past examples, because we only need to think about one scenario, and that scenario is where there is 1 even number and 3 odd numbers, and then we would just calculate the number of combinations for this, and that would be the number of combinations if we were to take exactly 1 even number. Okay. So that pretty much concludes this video on combinations with at least or at most or exactly. Thank you.